Today's lesson, we're going to take a look at what are called double angle formulas. So if you notice the list of formulas, we're taking the sine, cosine, or tangent of 2 times the angle. And for sine and tangent, we have one formula, but for cosine, we have 3 to choose from. Little word of caution before we get started is some errors that students typically make with evaluating the double angle expressions. So first of all, remember when we have sine squared of x. What that means is sine of x squared. We kind of shortcut it by putting that square up there. And it's sine times sine. Sine of 2x, this is one of those double angle formulas. And this is what sine of 2x equals. 2 times sine x times cosine x. Sine of 2x does not equal sine squared. So be careful with those notations. All right, so let's see how to evaluate using our double angle formulas. So first example, we're given a triangle. In order to set up sine and cosine, of course, we need to know the hypotenuse. So real quickly with Pythagorean theorem, we have 1 squared plus 5 squared equals c squared. And when you solve that, you get the square root of 26 for c. Setting up our double angle formula, sine of 2x equals 2 times the sine of x times the cosine of x. So substituting in those values, sine of x is 1 over the square root of 26. And I'm going to rationalize when I'm all done if I need to. Cosine is 5 over the square root of 26. So when we multiply, remember when you multiply by a whole number, it goes in the numerator. So that 2 is going to be multiplied in the numerator with my 1 and 5, and I get 10. And then the root 26's in the denominator cancel each other out. And when I simplify it, I get 5/13. Next, we have secant of 2x, which of course is the reciprocal of cosine. So what I'm actually going to do is evaluate cosine of 2x, and I'm going to take the reciprocal of it when I'm done. So for our cosine formula, we have 3 options to choose from. I'm just going to start with this one because it's at the top of the list. We've got cosine squared minus sine squared. So cosine was 5 over root 26. Sine was 1 over root 26. So when we square each of these, we have 25 over 26. Remember, when you take a square root and square it, they cancel each other out. Minus 1 over 26, so that gives us 24/26, which simplifies to 12/13. But of course, we were asked for secant. So secant of 2x is the reciprocal of cosine, so we get 13/12 for our secant. And finally, we'll take a look at our tangent formula. So we have 2 times the tangent of x all over 1 minus tangent squared x. Substituting our tangent value, tangent was 1 over 5 minus that 1/5 squared. And we do have a fraction within a fraction, so we're going to have a little bit of algebra on this one. So our numerator is 2/5. Our denominator is 1 minus 1/25. So when we simplify our denominator, changing that 1 to 25/25, so we have a common denominator, we get 24/25. And to divide fractions, we multiply by the reciprocal. So the first fraction stays the same. The fraction in the denominator gets flipped. So we can simplify 2 goes into 24 12 times, 5 goes into 25 5 times. So we have tangent of 2x equals 5/12. This next example is very similar to the first example. We're given a cosine value, so what I'm going to do is set up the right triangle. I'm also told we're in the second quadrant, so I'm going to set up my triangle in the second quadrant. Cosine is adjacent over hypotenuse, so then I'll use Pythagorean theorem again to solve for that missing side. So this time we have -2 squared plus, and I'm going to call it y because it's our y value, equals the radius squared. So we have 4 plus y squared equals 9. So y squared equals 5, and that missing side is the square root of 5. Once we have that, this is just like the first example. In order to save time on this one, I'm actually not going to set up all three of them. Really, the problem with this formula is the algebra when you end up with fractions within fractions. So that's really what you need to be careful of. And our last example, we are solving. So what I notice when I'm looking at this one is there's really nothing that I can do to figure out this solution. I can't factor it because they don't have a common factor. And I can't rewrite them as a common trig function because I still have that issue of the double angle on this one, whereas I do not have a double angle on the other one. So I'm going to start by substituting sine of 2x for its double angle, sine x times cosine x. And then I have a common factor with my two terms, and I can factor out that cosine function, leaving me with 2 sine x plus 1. And then I can use my zero product property, setting each factored piece equal to 0 and solving. So the first one we're looking at is where cosine equals 0. Remember, cosine is your x-coordinates when you're on the unit circle. Our x-coordinate is 0 up at pi over 2 and down at 3 pi over 2. For our second one, solving, subtracting 1 and dividing by 2, we're looking for where sine x is negative 1/2. Remembering that sine is our y-coordinate and sine is negative in the third and fourth quadrants. Thinking about the first quadrant reference angles, we've got sine is 1/2 root 2 over 2 root 3 over 2. So we end up at that pi over 6 angle. In the third quadrant, x would be 7 pi over 6. And in the fourth quadrant, x is 11 pi over 6. And your U-try question. So on this one, because the double angle formula for cosine has 3 options, you might want to play around with which one works best with that sine x.